Hi, this video is on atomic theory. In this video, you learn about the structure of the atom, isotopes, and electronic structure. Now, the atom is the smallest indivisible unit of matter. And this was initially demonstrated by Democritus, an ancient Greek philosopher around 400 BC. And it can be represented by a circle, and it contains 3 subatomic particles. So in the center, it's got the proton, and it also has the neutron in the center of the atom, and around the atom we have the electron. Now we can take a look at the properties of these subatomic particles. We can take a look at the mass. The mass on a proton is +1, and the mass on a neutron is also 1, atomic mass units that is, and the mass of an electron is negligible. It is 1 over 1830 approximately. We can take a look at the charge on these particles. The charge on a proton is +1, it's positively charged. The charge on a neutron is 0, it's neutral, doesn't have any charge overall. And the charge on an electron is -1. So if you look, the proton and the electron are oppositely charged particles. Now the proton and the neutron have a mass of 1, and they are located in the center of the atom. The electron has negligible mass, so all the mass is in the center of the atom, and this is known as the nucleus. The electrons occupy energy levels or shells around the nucleus, and most of the atom is empty space. Now we can take a look at, we can have different numbers of protons, neutrons, and electrons, and these are known as the different elements. And all the known elements can be found in the periodic table, like this one. From the smallest element, hydrogen, which has symbol H, all the way to the largest element, organism, which has symbol Og. Now, the atom I drew out for you was helium. It has a symbol He, and if you look closely, it's also got 2 numbers. So it had symbol He, and in the periodic table are 2 numbers, a 2 and a 4. The smaller number, usually the bottom number, is known as the atomic number, and it's also known as the proton number, and this number tells us the number of protons in the nucleus. The top number is the mass number, also known as the relative atomic mass, and this number tells us the mass of the atom. Now we know the mass is made up of the protons and the neutrons, and they weigh exactly 1 atomic mass unit. So this number is in fact telling us the number of protons and neutrons all together in the atom. So we have from the atomic number we can work out the number of protons, and we also have the mass number. And so from these 2 numbers we can work out the number of neutrons. So to work out the number of neutrons, we take away the atomic number from the relative atomic mass, and in this case it's going to be 4 take away 2, which is 2 neutrons. Now the elements are arranged in the periodic table horizontally in increasing atomic number. So hydrogen 1, helium 2, lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, and neon 10. And it continues all the way to the largest element, which is organism, which has atomic number 118. Now I'm going to take a look at the lithium atom, which has a symbol Li, and it has atomic number 3. And it has a mass number of 7. Now, the number 3 tells us it's got 3 protons in the nucleus, but it also tells us that it's got 3 electrons. Now, to work out why it's also got 3 electrons, we need to take a look back at the properties of the subatomic particles. Now, the electron has a charge of -1, and the proton has a charge of +1. And atoms are neutral overall. That means they don't have any overall charge. So to balance out the 3 plus charge of 3 protons, we need 3 negatively charged particles, 3 electrons. So the reason is that atoms are neutral overall, and we need the same number of electrons to balance out the protons. So the top number is the mass number, and we can work out the number of neutrons by taking away the atomic number from the relative atomic mass. And in this case, it's going to be 7 take away 3, which is 4 neutrons. So if you look, just by knowing the atomic number and the mass number, we can work on the number of protons, electrons and neutrons of an atom. So from this information, we can draw the structure of a lithium atom. It will have 3 protons in the nucleus, and it will have 4 neutrons. And around the nucleus, it will have 3 electrons, which will draw like this for the time being. Now, the actual relative atomic mass of lithium is not 7. It is in fact 6.9 atomic mass units. Now, what is the reason for this? We know that the mass of the atom is made up of the protons and the neutrons, and that they weigh exactly 1 atomic mass unit each. So does this mean we have a fraction of a proton or a neutron? And the answer is that we don't. We don't have a fraction of a proton or a neutron. And the reason is that there's another form of lithium that also exists. Now, I'll draw it out here for you. Now, this form of lithium has 3 protons in the center. That's what makes it a lithium atom. But instead of having 4 neutrons, it only has 3 neutrons. And we'll still have 3 electrons to make it a neutral atom. Now, the first form is known as lithium-7 because it has a mass of 7. And the second form is known as lithium-6. They both have an atomic number 3, so they have the same atomic number, but they have different mass numbers. And so these two are known as isotopes of each other. So we can define the word isotope. An isotope is an atom of the same element with the same number of protons. That's what makes it the same element, but it has a different number of neutrons. So if you see, lithium-7 has 4 neutrons, but lithium-6 has only 3. So I'll highlight this definition out for you because it is very important. And so lithium-7 is an isotope of lithium-6. Now, to go back to the original question, what is the relative atomic mass? Why is it a fraction? Well, now the relative atomic mass is an average mass of the 2 isotopes proportional to the amount of each isotope that we can find in nature. And this is known as the percentage abundance. Now, there are 2 naturally occurring isotopes of lithium, lithium-6 and lithium-7. And so lithium-6 has a mass of 6 and a percentage abundance of 7.8%. And lithium-7 has a mass of 7 and a percentage abundance of 92.2%. Now, if we take the mass of lithium-6 and multiply it by its percentage abundance, and then add that to the mass of lithium-7 multiplied by its percentage abundance, then divided it all by the total abundance, in this case 100%, we should be able to get that average. So we can now calculate the relative atomic mass from the percentage abundance of each isotope. And we have a mathematical formula for this. So the relative atomic mass is the sum of the mass times the percentage abundance of each isotope divided by the total abundance. Now, in this case, it's going to be 6 times 7.8, add 7 times 92.2 divided by 100. And so the relative atomic mass is going to be 6.9 atomic mass units. That is the relative atomic mass of lithium.